Okay, welcome to this GRE class today, and today we are going to be looking at quantitative reasoning aspect of GRE. And in the quantitative reasoning aspect of GRE, we have four aspects, which are arithmetics, we have algebra, we have geometry, and we have data analysis. So we are going to start with the first aspect, which is arithmetic. And in arithmetic, we have the following topics to look at. We have number properties, we have sequence, we have fractions, we have decimals, we have real numbers, we have ratio and proportion, and then we have percentage. So in this class today, we'll be looking at the first topic in arithmetic, which is number properties. So let's dive in. Now, under number properties, we'll be looking at these subtopics, which are integers. We'll talk about even and odd integers. We'll talk about factors and multiples. We'll talk about HCF and LCM. We'll talk about prime numbers. We'll talk about prime factorization. We'll talk about perfect squares. We'll talk about remainders. We have consecutive integers and also divisibility rules. So now we may not be able to run through all this in this class, but we'll try to cover as much as we can. I will continue complete it in the next class. Okay, now let's start with integers. Now, what are integers? Integers are positive and negative whole numbers, including 0. Now, note that 0 is neither positive nor negative. So, when we are talking about positive integers start from 1, because some students, when they hear positive integers, they think of 0. 0 is not positive and is not negative. Now, any number greater than 0 is a positive number, and any number less than 0 is negative. Okay, so examples of integers: we have -7, -4, -1, 0, 1, 2, 3, and so on. So now let's look at arithmetic of integers. Now, what do you mean by that? We're talking about the result we get when we multiply or add or subtract integers. So an integer multiplied by an integer gives us an integer, and also an integer plus or minus an integer also gives us an integer. So this means when we multiply two integers, we get an integer, and when we add or subtract two integers, we get an integer as our result. Now you may be asking that, okay, what if we divide two integers? Yes, it depends on the kind of integers we have. If we divide two integers, we can get an integer as our answer, and we may also get a decimal number as our answer. So that depends on the kind of values we have. Now, we have even and odd integers. Now, one fact you must know is that every integer must either be an even number or an odd number. Yes. So now, an even integer is said to be even if when divided by 2 yields a remainder of 0. So when we divide a number by 2 and the remainder is 0, then that number is an even integer. Examples are, we have -6, -4, -2, 0, 2, 4, and so on like that. So you can see that negative numbers also can be even, as long as when we divide by 2, the remainder is 0. It's an even number. And also note that 0 is an even integer. You may not know that, before, but now you know. So 0 is also an even integer. Now we have odd integers. An integer is said to be odd if when divided by 2 yields a remainder of 1. Yes. So when we divide an odd integer by 2, the remainder is always 1. So that's what we call an odd integer. So examples of odd integers: we have -5, -3, -1, 1, 3, 5, 7, 9, and so on like that. Now note that 1, if the last digit of an integer is even, the integer is even. And 2, if the last digit of an integer is odd, the integer is odd. So what does this mean? This means that if we want to know if a number is even or odd without dividing by 2, all we need to do is to check the last digits of this integer. So if the last digit of the integer is even, then that integer is even. And the last digit of the integer is odd, then the integer is odd. So for example, this number 4483 is an odd integer because the last digit is odd, and 7938 is an even integer. Why? Because the last digit is even. So when the last digit of a number is odd, the number is odd. And when the last digit of a number is even, the number is even. So when we just want to know if a number is even or odd, we can easily check the last digit. Alright, now we have arithmetic of even and odd. That is, when we multiply or add or subtract even numbers or odd numbers, what kind of result do we have? So first, even times even will give us an even result. Okay, and then also even times odd will give us an even result, while odd times odd will give us an odd result. So when we multiply two evens, we have an even result. When we multiply two odds, we have an odd result. When we multiply one even and one odd, we have an even result. As a matter of fact, when you are multiplying numbers, if all the numbers are odd, you have an odd result. But once you have at least one even number among them, then the result must be even. Yes, even if you have 1 million numbers and you have only one even number among them, then the result will be even. Otherwise, you will have an odd result. So that means for you to multiply numbers and get an odd result, all the numbers must be odd. Must be odd. Yes. Now, also when we are adding or subtracting, even plus or minus even will give us even. Even plus or minus odd will give us odd, while odd plus or minus odd will give us even. So when we are adding or subtracting, we just take the numbers by pairs, pair by pair. So two evens, the sum or the difference will be even. Two odds, the sum or the difference will be even. While one even, one odd, their sum or the difference will be odd. So now let's get this simple example on this table. It says if A is even and B is odd, determine whether the following is an even or odd integer. So you may pause the video and then try to solve this by yourself and see what the result will be. Okay, now let's check out the solution of this. Okay, so let's look at this simple arithmetics of even and odd numbers. Now recall that our A is even and our B is odd. So from this first one, we have 3, which is an odd number, multiplied by A, which is an even number. So that means odd times even, which gives us an even result. So minus B, which is an odd result, odd number. So which means we have even minus odd. And what does that give us? Gives us an odd number. For the second one, we have 2, which is an even number, multiplied by A, which is another even number. So that is even times even, which gives us even. So plus odd, which is our B, then we have even plus odd, and that gives us an odd result. Also for the third one, A is even and B is odd. So this means even times odd, which gives us even. Then minus 1, which is an odd number. So even minus odd is odd. For the fourth one, we have a raised to power b, and our a is even, which is now raised to an odd number. Well, our odd number could be 3, could be 5, could be 7, but it still simply means we are multiplying even numbers. If our odd number is 3, that means we will have even times even times even, which is going to definitely result in an even number. Fifth one, we have a plus b, that is even plus odd, and that gives us an odd result. So that means odd squared, which means odd times odd, and odd times odd will give us an odd result. Then the last one, we have a squared, which is even times even, that will give us even. Then minus odd squared, which is odd times odd, which will give us odd. So meaning we have even minus odd, and that gives us an odd result. So as you can see, that is how you can easily find the result of our arithmetic of even and odd. Okay, all right, so hope that is clear enough. Now we have factors and multiples. Now when you say factors, what are we talking about? Now factors of an integer x are all positive and negative integers that can divide integer x with a remainder 0. E.g., factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So when we talk about factors of a number, you're talking about numbers that can divide that integer with a remainder of 0. So factors of 12, numbers that can divide 12 with a remainder of 0. So 1, 2, 3, 4, 6, and 12. And their negatives as well. They are all factors of 12. Now, factors are also called divisors. So that's another name we call factors. Now note, all factors are divisors, but not all divisors are factors. Now, what are we saying here? For example, when we divide, let's say 25 by 4, we have 6 remainder 1. Now this 4 is called a divisor, but as it is not a factor because it doesn't produce a remainder 0 when we use it to divide 25. But if I divide 24 by 4, I have 6 remainder 0. So here this 4 is also a divisor, but since it produces a remainder 0, it is also a factor. So when you use a number, any number used to divide another number is generally called a divisor. So it is possible for that divisor to be a factor and it may not be a factor. So that is why all factors are divisors, because they are dividing another number. But not all divisors will be factors. Alright, so that is exactly what we are trying to explain there. Okay, now multiples. Now multiples of an integer x are all positive and negative integers that are divisible by x with a remainder of 0. E.g., multiples of 3 are plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 15, and so on. So when you're talking about multiples of an integer, you are talking about numbers that the integer can divide with a remainder of 0. So if I'm talking about multiples of 3, I'm talking about all numbers 3 can divide and will give me a remainder of 0. So 3, 6, 9, 12, 30, 300, 300 million, 30 billion. All these numbers are multiples of 3 because 3 will divide them with a remainder of 0. So multiples are unlimited since numbers have no end. So same with multiples, continuous. Alright, so that's what I mean by multiples. So As you can see, multiples and factors, they are very related. So for instance, 24 divided by 6 is 4, remainder 0. Therefore, this 6 is a factor of 24. Since it produces remainder 0, we use it to divide 24. While 24 itself is a multiple of 6. Okay, so, and you must also note that this 4, that is the quotient answer, is also a factor of 24. So if 6 can go in 24 with the remainder 0, then 6 is a factor of 24, while 24 is a multiple of 6. So that is how the two of them are related. So now note that 0 is not a factor of any integer. That is, 0 cannot go in any number. If you divide a number by 0, you get an error. Calculator will tell you mathematical error. So it is undefined. So 0 cannot be a factor. While 1 is a factor of all integers. So 1 can go in all numbers, in all integers with remainder 0. So 1 is a factor of all integers. See, 0 is a multiple of all integers except 0 itself. That is, 0 divided by any number is always 0 with remainder 0. So that means 0 is a multiple of all numbers. But 0 cannot divide itself. So 0 divided by 0 is undefined. 0 divided by 0 is undefined. But 0 divided by any number is going to give you an integer with a remainder of 0. So 0 is a multiple of all integers. 1 is not a multiple of any integer except 1 and minus 1. So 1, no number can go in 1. No number can divide 1. 1 is not a multiple of any number except you use 1 to divide it or minus 1. So those are things you should note here. Alright, now we have HCF and LCM. Now HCF means highest common factor or greatest common divisor. Okay, so the HCF of x and y is the biggest integer that can divide x and y with a remainder of 0. So for instance, the factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now, the common factors of these two numbers are 1, as you can see, we have 2, we have 5, and we have 10. Now the highest common factor is 10. Okay, so that is alone by highest common factor. So this means this is the biggest number. This 10 is the biggest number that can divide 20 and 30 with a remainder of 0. That's the highest common factor of 20 and 30. So that's what we mean by HCF or greatest common divisor. Then we have LCM, which is lowest common multiple. So the LCM of x and y is the lowest integer that can be divided by x and y with a remainder 0. That is the lowest number that x and y will divide. with a remainder of 0 is the lowest common multiple of x and y. For instance, multiples of 20 are 20, 40, 60, 80, 100, 120, 140, and so on. Multiples of 30 are 30, 60, 90, 120, 150, 180, and so on. Now, the common multiples here, as you can see, we have 60, we have 120. So, and if we write more of the multiples, we will see more common multiples. And from this, the lowest common multiple is 60. So this means this 60 is the smallest number that both 20 and 30 will divide with a remainder of 0. So that's what we call the LCM of 20 and 30, the lowest common multiple. Okay, now note that A, the product of the HCF and LCM of two integers is equal to the product of the two integers. Again, the product of the HCF and the LCM of two integers is equal to the product of the two integers. What are we talking about here? Now, for instance, the HCF of 20 and 30 is equal to 10, just like we found it the other time. And also the LCM of 20 and 30 is 60. So we are saying that the product of the HCF and the LCM of two integers is equal to the product of the two integers. So let's see. The HCF 10 times 60 is equal to the product of the two integers 20 times 30. That is 600 equals 600, and which is true. Okay, so that is what the rule is saying. So this rule is applicable to just two integers, not more than two. The product of the HCF and the LCM is the same as the product of the two integers. Alright? And B, the common factors of two or more integers are the same as the factors of their HCF. Again, the common factors of two or more integers are the same as the factors of their HCF. So, what are we saying here? The factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Let's take one more number. Factors of 60. We have 1, 2, 3, 4, 5, 6, 10, 12, 15. We have 20. We have 30, and then 60. Okay, so now the common factors for these three numbers are 1, that's factors common to the 3. 1 is there, 2 is there, which other one you can see? 5 is there, yeah, another one, 10 is there, yeah, and another one. Okay, so we have 1, 2, 5, and 10. Now, the highest common factor for these three numbers is 10. Okay, now let us look at the factors of 10, which are 1, 2, 5, and 10. So as you can see, the factors of the HCF, they are the same as the common factors of the numbers. Okay, so that is what we're really saying, that the common factors of two or more integers are the same as the factors of their HCF, or we can say the number of common factors of two or more integers is equal to the number of factors of their HCF. Alright, so that is what that rule is simply saying. Okay, so now let's look at the methods we can use to find our LCM and HCF. So 1, we can use what we call long division method, and 2, we can use what we call prime factorization method. Long division or prime factorization method. So anyone you are comfortable with, you are free to use. Definitely in GRE, they will never ask you to use any method, so you can always pick any method you prefer. So let us look at this example 1. Let's look at some examples here. So example 1 says, find the HCF and LCM of 10, 40, and 100. HCF and LCM of 10, 40, and 100. So let's look at using first the long division method first. Alright, using long division. So now to find HCF of 10, 40, and 100. Now what do we do here in long division? All you have to do is just make a table like this, and we have 10, 40, 100, and now we divide by a common factor, that is a number that you know will divide all these three numbers at a go, and the least is 2. If you have a bigger number you can pick, you can do that just to save your time. So but let me say I'm taking it gradually. So starting with 2 in 10 we have 5, 2 in 40 we have 20, and 2 in 100 we have 50. And as you can see here, a number that will go in these three numbers here is 5. And 5 in 5 we have 1, in 20 we have 4, and in 50 we have 10. So that is how we can do. Alright, the only number that can divide this three number is 1, and there's no need doing that. So it means our HCF will be 2 times 5, that's this times this, and that will give us 10. So that gives us the highest number that can divide these three numbers with remainder 0. Now let's say we are finding the LCM using the same method. Alright, long division for our LCM. Long division. Now LCM of 10, 40, and 100. So we'll do the same thing. Draw your table. We have 10, we have 40, we have 100. So here we are free to start with any number. As long as the number can divide at least one of these numbers, we are good to go. So 2 in 10 we have 5, in 40 20, in 100 50, and I can go with 2 again because 2 can divide 20 and I can also divide 50. So, but cannot divide 5, so I still have 5. And in 20, I have 10. In 50, 25. Can still go with 2 because 2 can go in 10. So I have 5. In 10, 5. In 25, I still have my 25. Now, next I can do is 5. So 5 in 5, we have 1. Here we have 1. Here we have 5. Then 5 again. Then we have 1, 1, 1. So it means our LCM will be equal to 2 times 2 times 2. That's 1, 2, 3. Times 5 times 5. So which gives us 2 times 2 times 2 is 8. 5 times 5 is 25. So 25 times 8 will give us 200. 200. That is the LCM of 10, 40, and 100. Alright? Okay, so we have 200 as our LCM. So this is how we can use the long division method to find the HCF and the LCM. Now, let's check the second method, which is prime factorization method. Now, in prime factorization method, which we'll still look at later, we try to express the numbers in prime factorization in order to find our HCF and the LCM. Now, using prime factorization method, now to find the HCF of 10, 40, and 100, so we express each number in prime factorization. 10 in prime factorization is 2 times 5. 40 is 2 raised to power 3 times 5. 100 is 2 raised to power 2 times 5 raised to power 2. Now, to find our HCF, we look for the common factors. That is, factors common to these three numbers. And as you can see, 2 is common, 5 is common. So you pick only the common ones. If there's any factor you can see here that is not here or here, then you cannot pick that factor. You pick only the common ones. And now we have to look for the one with the lowest power. So here we have 2 raised to power 1, we have power 2, power 3. So we have to pick power 1 times, for 5 as well, power 2, power 1, power 1. So we take the lowest power, which is power 1. So our HCF will be 2 times 5, which is 10. So that is how we use the prime factorization method to find the HCF. And then to find the LCM of 10, 40, and 100. So same process, express the numbers in prime factorization. So 10 is 2 times 5. 40 is 2 raised to power 3 times 5. While 100 is 2 raised to power 2 times 5 raised to power 2. Now here, for the LCM, we pick all factors you can see, either common or not. Either common or not. You pick all factors available. And here, all the factors available are actually common. So if you see anyone that is not even common, you pick it as well. Now, we have to pick the one with the highest power. So for our 2 now, we have power 2, power 3, power 1. So we pick power 3. Then for our 5, we have power 1, power 1, power 2. So we pick power 2. So 2 raised to power 3 is 8. 5 raised to power 2 is 25. Which gives us 200. So that is how we can use the prime factorization method to find our HCF and LCM. Okay. Now, example 2. It says the LCM of two numbers is 48 and the HCF is 4. If one of the numbers is 16, find the other number. So, this is talking about the LCM and the HCF, the products and all that. Now, from this question, you can recollect the rule that we can apply for this. So if the LCM of the two numbers is 48 and the HCF is 4, and the question says one of the numbers is 16, so what is the other number? Now remember the rule that says the product of the HCF and LCM of two integers is equal to the product of the two integers. So this means if you multiply the HCF and the LCM, the product must be equal to the product of the two integers. So now from this our question, now we have the LCM to be equal to 48. We have HCF is equal to 4. And the question says one of the numbers is 16. So let's say let the other number be x. Then according to that rule, it means 16 times x must be equal to 48 times 4. That is, the product of the HCF and the LCM and the HCF is equal to the product of the two numbers. So this means 16x is equal to 48 times 4. Therefore, we can say x is 48 times 4 divided by 16. So as you can see what I'm doing here, you don't need to bother yourself to multiply these two and get them as a whole number or as a single digit, as a single number, because in GRE all these things happen, so this can always cancel this out. So just leave it like that. Don't waste your time multiplying or press a calculator. So here 16 here 1 and 16 in 48 is 3. So 3 times 4, this means our x is equal to 12. So it means the other number is 12. So we've been able to find the second number. Okay, so that is the solution to example 2. The other number is 12. Now on to the example 3. It says on a radio tower, a red light flashes every 6 seconds and a blue light flashes every 10 seconds. Now if both lights flash together at a certain time, how many seconds later will both lights flash together the next time? Alright, so we have a question talking about two lights here. One light, the red one, flashes every 6 seconds, and the white or the blue one flashes every 10 seconds. So if both lights flash together at a certain time, how many seconds later will both lights flash together the next time? Okay, so how do we answer this question? What are they trying to ask us here? Now let's look at the solution of this. Now the red light flashes every 6 seconds. So that means if the red light flashes now, then in the next 6 seconds it will flash again. Then in the next 12 seconds from now it will flash. That's every 6 seconds. That means 18 seconds from now it will flash again. 24 seconds from now it will flash. 30 seconds from now it will flash. 36 seconds from now it will flash. 42 seconds from now it will flash, and so on like that. Alright, so that is the red light. Every 6 seconds it will be flashing. Now for the blue light, it flashes every 10 seconds. So that means if it flashes now, in the next 10 seconds it will flash. In the next 20 seconds it will flash. In the next 30 seconds from now it will flash. In the next 40 seconds from now it will flash. In the next 50 seconds from now it will flash. In the next 60 seconds from now it will flash, and so on like that. Now the question is asking us that if the two lights flash together now, how many seconds later will they flash together again? Like how many seconds from now will they flash together again? And from what we are seeing here, it means that will only happen at this time. That is 30 seconds from now. That means 30 seconds from now, two of them will flash together again. So the two lights will flash together after 30 seconds. Alright, now what can we notice in this solution? You will notice that all these periods of time for red light, they are multiples of 6. While all this period of time for blue light, they are multiples of 10. So, and if you check, the lowest common multiple here is what? 30. So simply the question is asking us LCM. So the question is simply about LCM. So all they actually want us to do is to find the LCM of 6 and 10. So in GRE, they will never ask you find the LCM of this or find HCF of that. They put it in words like something like this. So simply you don't need to waste your time doing all this. All you need to do is, if they ask you, if they tell you one person will do so a job or will do so period of time, like every 2 seconds or 10 seconds or 10 minutes, and another person will also do every 3 seconds, or another light will flash every this and that, and they're asking you if they do the job together now, how many seconds later or how many minutes later or how many days later will they do the job together again. So it's all about finding the LCM of their periods of time. So just simply here, LCM of 6 and 10. So if we use our long division method, 6, 10. So we have 2, 3, and then 10, 5. Then we can have 3, which is 1, 5. Then we have 1, which is 1, 1. So which means the LCM will be 2 times 3 times 5, which is equal to 30. So that means after every 30 seconds, they will be flashing together. That's what this simply means. After every 30 seconds, the two lights will be flashing together. So this is simply a question on LCM. So this is just how you can easily come across it in GRE. Alright, so this is where we'll be stopping for this class today, and the next class, yeah, we will continue. We are still talking about number properties. So I want you to go over this again and then get ready for the next class. So see you in the next class. Thank you.